The advent of a blockchain has revolutionized the tech industry, but does it hold the capacity to sweep cloud from the market? Will cloud be able to retain its position in the face of disruptions, or its presence is short-lived in the world of digital advancements? Let's welcome up to the stage Mr. Suhas Patil, founder and CEO of Sankey Solutions, to answer these questions along with many others related to the aspects of blockchain and the cloud.
Good morning, everyone. My name is Suhas Patil. I'm a founder and CEO of Sankey Solutions. So we all, in the age of disruption, we all talk about electric vehicles disrupting traditional industries. We talk about AR, VR disrupting traditional viewing experiences and payments and all that. We all talk about disruption, new technologies disrupting traditional technologies or traditional legacy systems. Here today we're going to talk about, can blockchain disrupt cloud? Now, how many of you think that blockchain and cloud are two pillars of a digital transformation that we all talk about, and they're not related? This question is not even valid. How many of you guys think like that? Raise your hands. Okay, so you all agree that this is going to disrupt? Well, I'm sure while we all know that these technologies by intrinsically are evolving and have a high potential to disrupt each other, I want to walk you through few things, few of those predictions that we're already looking at, which might actually, might make the cloud that we all talk about irrelevant for future. And how and what, let me just give you a brief of that. So cloud, let's start with what's the drawbacks or limitations of cloud that might potentially make it as a potential candidate for disruption, right? And the first thing, we all know that we started all with single machine, very local computing at very early age, moved to an enterprise on-premise servers, right? So that we all can share the computing power and storage. And from there, virtualization happened, and that technology changed. That technology enabled to take that computing and storage and put it on a centralized place somewhere outside the enterprises. Now, this has happened just recently, right? We last 4 or 5 years, we have seen a lot of surge in the cloud. We moved from licensing to a subscription model. So disruption is already, cloud is already disrupting a lot of these things, and how can we now say that cloud itself will get disrupted, and what will be the impact of that? So that's very interesting thought to look at, and how it impacts our future. So let's look at what are the limitations of the clouds that that actually can make blockchain alternative. Now, we all seen in the last 2 days multiple panel speakers talking about IoT, right? And how IoT devices, if it all takes off, is going to create 850 plus zettabytes of data, right? We all just I think, day before in one of the sessions we saw. So if you see on the graph here, on the bottom is the black line is the capacity available in the cloud today to manage compute and storage. And what you see on the blue line is the data that we're going to create in next 5 years to 10 years. Now, there is absolutely no way that the data that we're going to create at so many places outside the cloud centers can be actually stored in our cloud centers. Capacity, cloud, there's no way AWS, Azure together can even meet the capacity that's going to create it from the data. To give you an example, driverless car, we all talk driverless car is the future, right? Driverless car creates 1 GB of data per second. So if you're traveling to a grocery store for 10 minutes, it's going to create 1 terabyte of data. Right? So you can see the volume of data that's going to be created outside these cloud centers, data centers, and outside the enterprises. That's going to define whether cloud will be relevant or not. Now, that's for the storage. Now let's look at Now, if you have this in the pyramid with so many data centers, interim nodes, and then you have a lot of billions of devices. Now, all these devices creating terabytes and terabytes of data, billions of devices, does it make sense to bring them back to the data center, analyze it, and then send it back the insights back to the devices? That's absolutely impossible. It's going to be impossible if that is the state we look at in the future. So if we, essentially, the data that you're creating at the edges, at the devices, has to be computed at that point of time, and the insight has to be thrown back at that point of time. There's no way we could bring this all back into data center and take it back. So computing is going to be the biggest bottleneck, more than even storage. Storage, assume we still put thousands of data centers and put the hard disk. The computing ability not having at the edge of those devices I think is going to be the biggest bottleneck of this whole change. Now, most importantly, let's look at the cloud state of today, right? When we work with CIOs, CTOs, we know a lot of organizations have moved to cloud. We know that there is acceptance that the cloud is definitely cost-effective and is needed, but more than 50% of mission-critical systems still are on-premise. Take any bank, none of this, even the core and sub-core systems will be on cloud, right? A lot of these will be on the peripheral systems are on a cloud. And fundamentally, cloud does not address the accountability and the trust factor of what the CTO and CI wants. If today a bank loses the data and if it has to fight a war with Azure AWS, it's absolutely no way that these guys are going to likely to win in any of that conflict. And I think a lot of CIOs don't want to put that risk or take that risk, and hence you'll see that even if next 10 years, if cloud remains, the cloud will never become a replacement of the entire on-premises. There will be a hybrid structure till there is a better alternative for cloud, right? And I think given where we are looking at going with all these new technologies, there is going to be need for creating the decentralized environment. Now, one other theme that's happening quite significantly is many of you technical guys who are building our applications would have seen that we recently started building our applications in a newer architecture called microservices. So essentially, you don't build application as a one unit, you break it into smaller units. And there's a lot of technologies and tools that have evolved in the last 4 or 5 years. So and in general, even if in a cloud, we are trying to break the systems into smaller units and spread it across. So what it tells is that the decentralization is a big theme that's happening in technology. And another example that I see is a lot of you use the coding repositories, right? So traditional TFSs and SVNs to Git is a big change from centralized repositories to a decentralized repository. So in general, a lot of technologies that we're working on underlying are actually moving and becoming decentralized. We still live in cloud where all our applications sitting at one place or one data center, one vendor, but all our systems, we are trying to create that decentralization. So in my mind, there's absolutely no question that if we want to see the future that we are talking about, the future of IoT, future of AI driving things in real time, driverless car, there is no alternative other than figuring out how to make computing and storage decentralized. And I think that question is not solved. We will actually not reach the potential of what we're talking about, all its technologies that we're talking about. Now, let me give you some examples. Is decentralized enough, right? Can just decentralizing the compute and storage across the internet, will that be enough? Let me give you some examples that where this has been attempted, but there was no alternative or better alternative that resulted in replacing cloud. So this is an interesting project that happened in University of Berkeley, which is called SETI at Home, stands for Search for Extraterrestrial Intelligence at Home. So these guys wanted to analyze the radio signals coming from space and see if some extraterrestrial people are sending the wave. So they want to separate out the noise and signal and see if someone is sending signal to Earth from the space. And in order to do that, this computing power of the project at Berkeley is not enough. So these guys started an idea that we'll create a software which will sit as a screensaver on the laptops of people. And that's whenever you're not using the machines, the CPU is still running, right? They will use that CPU to mine that data and have millions of analysis done in real time. Now, interestingly, this started in 1999, and they ended up having, in 2005, the peak time, 5 million laptops were connected as a distributed computing, where they were able to get people to download that and then have 5 million people's CPU utilized whenever they are free. Now, problem with that was, and this was one of the most successful I can think of as most ambitious decentralized computing project ever conceived. But there was a drawback, right? And there was a big drawback was, what is the reward for joining it? And what the reward that University of Berkeley was giving was a certificate of computation, saying that you have donated X percentage of CPU of your machine to University of Berkeley. Now, to be able to sustain and scale that kind of reward system is probably not going to be that's going to be the system that we'll need. I think parallelly, while we talk about this cloud, there's a lot of these P2P technologies that are running in the parallel. So if you see, all of us, of course, we have heard examples of Napster, BitTorrent, and all this that still undergoes so many peer-to-peer file transfer across the world, is another successful example of decentralized system is working. Now, there are some drawbacks in it, where the biggest drawback is highly insecure, because there is no governing authority which will decide the contract between the systems. And as a result, there are a lot of freeloaders, right? People, I'm sure you heard the people download the torrent, but they never upload anything, or they can restrict upload. So there is no system that governs this, but as a technology, as a P2P, peer-to-peer distributed computing, is something that exists today and is already being used. It's just that it's being used for wrong purpose. Now, let's look at the alternative now, the alternative that we're talking about here is blockchain. Now, blockchain has all the capabilities that can address the drawbacks that we talked about in the P2P technology. The first and foremost is efficiency. When I say efficiency, imagine the cloud took the centralized, or created the processing and computing at the centralized places. But imagine the power of blockchain. If blockchain can take a slice of can slice all that computing power and spread it across the internet devices. Now, the power of harnessing such computing at a large scale, that technology is only available in blockchain. And that's what I think it makes very interesting. The other part, security, which we talked about cloud, right? The issue with the trusting with the vendor or trusting with the third party. Now, we all create redundancy in our applications. When we say redundancy, I mean when you start an application, we always create replicas. You create you set it up across different zones. So make sure that it's a de-risk, right? If one fails, it doesn't matter. The blockchain inherently creates this redundancy by replicating these nodes at all the different levels across the system, which creates so much redundancy that there's no way you can hack the system. And we all know all the basic concept of blockchain. But it's especially if this applied in the context of cloud, that can be even more powerful. The other thing is accountability. So one other thing that we all know about blockchain is the consensus system, right? There is a recording of what happened by everyone, and that gets recorded in everyone's system, right? So naturally, there is a clear accountability of what happened when, and it's something that cannot be hacked. So from the CIO and CTO perspective, there is always a situation where we know that things will not be hacked, and at the same time, there's a clear audit trail of changes that are happening in the system. And the most importantly, I think the biggest thing that I believe blockchain brings to the table is the tokenization. And we all talk about the currencies and so forth. I think if you leave the financial application of the blockchain aside for a minute, I think the inherent ability to create the token and reward the point system for all the nodes creates that tremendous opportunity to leverage this computing power in the world and then reward that each node accordingly based on the usage of and the contribution of that. So that, to me, is one of the big differentiators that will make it commercially viable first time compared to the P2P and the Sankey projects that we saw. Commercially viable to create a distributed computing model, and that should lead a lot of business models, change in the business model. Now, I'll come back to the same question that we asked: will blockchain disrupt cloud? I think, given what are the premise and the context I mentioned, I think it's very highly likely that we are going to see the disruption of cloud as well, because blockchain is a natural extension of the computational architecture of cloud, right? It's a next generation computational ability of cloud. Now, we just talked in the previous session that data is new oil. Now, the underlying assumption of that sentence is that data is enterprise data, is sitting in the corporates. Future data is not going to sit in this corporates or enterprise. Future data is going to sit in your car. The terabytes and zettabytes of data sitting on your car, sitting on your new devices. So as a result, if data is new oil and data will remain new oil, I think the processing power and the processing of that oil, ability to do the processing at the local site, to me is going to be the critical driver to harness whether the data can be converted into insights or not. The biggest, another biggest attribute of data that's going to create it is not all data can be saved, and it's going to have shelf life. So we saw the 4 V's of data, right? The velocity, variability, and things like that. I think one of the main dimensions of the data is going to be the shelf life. And that aspect we don't generally think about, right? The data, how come data has shelf life? Data is going to be there. The use of the data is going to lose. The value of the data is going to lose if you don't action on that, right? For example, when you're talking about a driverless car, the information that you got real time, if you're not actioning that into inside that time, the image that you captured has no value, or the data that you saw from the camera has no value. So essentially, the war to me in the future war of technology is not going to be only about data. It's going to be about computing power. Can we have a tremendous, infinite computing power to manage all the data and have the algorithms that can manage and create this in the real time? I think that if we are able to solve, I think the blockchain definitely shows as a viable option for us to solve that. Now, I don't mean that the current state of blockchain is going to be the one who's going to replace. I don't mean that. I strongly think that the blockchain in the current state has to evolve a lot. There is a huge change that is going to be needed in multiple layers of blockchain, right from how you manage the consensus programs. The current consensus programs are very, very limited to a certain set of rules. There's a lot of consensus programs or algorithms that are going to come. As you see today, newer and newer deep learning algorithms keep coming. I think you are going to see a lot of these consensus companies coming and building newer algorithms to build the consensus. So someone who has to manage this most optimally or efficiently all the devices and all the computing, that algorithm is going to win. And I think that's where a lot of changes has to come. A lot of the basic components of technology, like databases, the file storage, have to evolve as well. A lot of new open source companies are actually coming today who are coming and constantly creating better ways to use distributed computing to manage file storage in databases. Application layer, how you manage software. I think at every level of the blockchain pillars and the layers of blockchain has to evolve. And I think in a few years, we might reach to an inflection point where, and I'll show you some examples down in the next few slides, but we'll reach some areas where we think the trend is already happening. We are seeing already a shift towards happening, and if we come to inflection point where you won't be surprised tomorrow, 2 years down the line, a new WhatsApp is not coming from data center, it's coming from distributed computing across the world. And I think that day, I don't think it is far away. However, these changes need to happen, and it has already started happening. As I mentioned, I think from distributed services, storage, database, computing, all pillars of that has to evolve, and there are multiple newer players that will emerge in each of these layers, and they also have to now build a most efficient system to manage this. Now, let me show you some examples of some of the recent things that are happening. We all know Azure, AWS, and GCPs are the major players. The EOS Tron Ethereums, we all know you're using for building the blockchain, but these newer players are actually trying to create the bigger infrastructure and ecosystem wherein they can manage the entire application layers. So forget about just using for cryptocurrency. I think a lot of developers today are actually exploring options to create applications on these platforms. So if you ask some of these Silicon Valley companies who are actually building next generation applications, they are potentially exploring the huge amount. Can we move from traditional client-server architecture to a distributed architecture, and can we build applications in a different way? So there is definitely interest and quite a bit of engagement and open source contribution that's happening in all three spaces. The amount of developer ecosystem of Ethereum has seen a significant increase in the last 2 years, on a 35% quarter-over-quarter developer ecosystem and building new technologies. We are also seeing a lot of new players trying to innovate in other layers as well. While there is a company like who are trying to replace AWS and Azure, there are a lot of companies who are trying to build this, as I said, next generation consensus mechanism. So Anchor, for example, has created, Anchor is one of the leading company where they created a hybrid solution where only the OS is on cloud, all other things are outside on the distributed, right? So these guys are trying to create something, mechanism that will help people to shift. Same way, Dfinity and Solana is some of these platforms which have recently published a new consensus algorithm where there's a proof of useful work versus a proof of history and so on and so forth. I'll not get into the technical details of that, but essentially, consensus mechanism should enable more and more efficient management of the nodes of the blockchain. I think that is the biggest research area for us to kind of expand and see how we can have ability to manage that millions of devices by a one blockchain system. Already, as I said, one of the biggest trend of this whole shift from cloud to distributed is DApps, distributed applications. I'm sure you also would have heard about this, but traditionally how we build you take an Amazon machines, you take RDSs and S3 buckets to manage data and all that. I think already you see that, if you know the examples such as Vault, and I'll show you some examples more, but there are already products which are getting adoption, which are built on a newer technology, completely rewritten onto a newer architecture. And newer architecture is based on the basics on Ethereum, file storage. There's a new player called IPFS or even Storj. The U-port for identification, like we use the Cognito and of AWS to use the authentication. There's a U-port and this third-party systems which are coming out as an ecosystem. So as you can see, there's a parallelly, there are two ecosystems that one is established, one is evolving. And I think this whole system where an application has contract using Solidity, the code changes that you see, release management and the application is managed through a consensus. By only then the code will get implemented. So imagine how much that blockchain, different capabilities that we talked about applied in the application setting can revolutionize the entire cloud. And some of these examples here, just to give you, we all talk about Web 3.0, and Web 3.0, there's always talk about DApps is going to drive Web 3.0. And as you see the shift, if you ask me the Dropbox of where we use the file storage system, it was already kind of on a distributed architecture. Now even from the Dropbox to Storj is another big shift that will enable taking ownership of Dropbox to giving it to an entire decentralized space. So in short, summarizing what my whole point about that the blockchain is going to revolutionize the next 10 years, especially if we want to, blockchain is $1 trillion industry, close to, cloud is close to $1 trillion industry. But if blockchain can enable IoT and AI, where you have a huge computing nodes connected across the world, where the AI system can, and a sophisticated AI consensus system, which can manage those devices and analytics at the edges. And if you can build that system that is centrally governed by a contract, so you're not just P2P, but you have a system that also has rules, we can eventually convert this trillion into a multi-trillion dollar industry. And I believe blockchain is going to be an enabler of IoT and AI in the long run. And most importantly, I think we all, as a system, we talk about trust, right? When you're talking about any application, any third-party software, we all talk about trust. I think that's whole paradigm of trust has to shift from showing the proof of the truth. And the truth here is something that blockchain only can provide, because it will be unhackable, it will have a huge redundancy, and it's the only way to know what happened in the system. So with that, I conclude my rest my case, and I open up for last few minutes if any questions. Yeah.
Any questions from the floor at this time?
There's a question.
Can we get a microphone over there, please? Thank you.
Suhas, it's a wonderful presentation.
Thank you.
I have two questions. One from the user perspective, and from the other one is from the cloud service providers. So when the blockchain is disrupted and cloud is going down, so what happens to the user applications in the current cloud? How are they able to, migrate from cloud to blockchain?
Yeah. Okay.
So is that feasibility available? And this is from the user's perspective. And from the, cloud service providers, when they wanted to transform themselves into a blockchain company from cloud-based, so how is that feasible?
Yeah.
So is there a provision?
Correct. Good question. So first question was what will the impact of the existing application? How do you move from a traditional cloud? How do you migrate to a newer architecture? I think fundamentally, as there are two different architectures, it's just there's no simple way to migrate. I think the reason I say cloud is going to disrupt, blockchain is going to disrupt cloud, is when it's not going to disrupt only cloud, it's going to disrupt the entire ecosystem. So all the software that we talked about, the Web 2.0, potentially cannot just be migrated to 3.0. So it has to be rewritten. The new ecosystem has to evolve, which is why there's going to be inflection point. There's going to be a lot of time going to take to do that. But at the end, people have to just rewrite a lot of these client and server-side technologies to a newer ecosystem. I think there is no other alternative. But there will be an inflection point where it will make economical sense to do that. And that, I think, period is when till that the system has to evolve.
But if they wanted to rewrite the application, it incurs a lot of cost.
Exactly. No, so as I said, the cost of maintaining current system versus what you're losing. So this inflection point of this shift will happen when, as an enterprise, you have a mobile app. You're giving it a mobile app, and that mobile data is sending out the application to a server. So you're okay. Tomorrow, if that mobile app is going to create a lot of data, mobile app is going to connect it to the car and is going to do a lot of intelligence at that user level, that's when you know that your current architecture will not work. And that's when the business value, the business opportunity is created enough to migrate that shift from technology. So look, we have moved from mainframes to the open source. We have moved from on-premise to those. So those, a lot of times, we just now have migrated. We had to kind of often, when the fundamental radical shift happens, we have to recode. And I think part of that is going to be recoded. However, I believe in the interim, there will be hybrid systems too, like what we saw in Anchor, right? Where OS only is virtualized. but the rest of the part is still is distributed. So you might see a small interim players who help to migrate part of it, keep it hybrid, and then slowly it evolve into complete distributed.
Okay.
Yeah, and the second question with respect to, what was the second question, sorry?
Second question is with respect to the cloud service providers.
Yeah, correct.
So
Look, I think AWS and all Azure today know that this is coming. So just 2 months back, AWS actually did a partnership with ComSense to actually create a blockchain on the cloud. Fundamentally, blockchain is not restricted to cloud. The whole purpose of blockchain reduces if you say blockchain is on cloud. That doesn't make sense, right? So blockchain has to be multi-cloud. Blockchain has to have boundaries beyond a specific data centers. So I do believe that these guys are going to also research and put a lot more, get into this newer, research and development on newer algorithms that can help them to build. But at some point of time, they will have to shift from the local infrastructure to managing that distributed consensus layer. So they have to shift from someone who's managing hardware to move up and play the intelligence layer game and then leave the hardware and to all the edges. So that shift will also happen in the business model of cloud. But depending on how fast these guys adopt, based on that, I think this will happen.
Yeah. Thank you, Suhas.
No. Any other question? I think we are timed up. Any one last question? Okay.
Good.
Thank you so much.
Thank you very much, Suhas. Thank you. That's a very informative chat.